Today we're going to derive the continuous compound interest formula, which is A equals P times E raised to the power of R times T. I guess in class we always just say A pert because it's quick and easy, but what it means is the final amount is equal to your principal times Euler's number raised to the power of rate times time in years. And Euler's number is given by this definition here, limit as x approaches infinity of 1 plus 1 over x raised to the power of x. So we'll use that in our explanation today, as well as these hints that I was given. So we'll start with the compound interest formula. We derived that last time. Oopsies. And I'm going to right away substitute in here, instead of r over n, I'm going to use 1 over n over r. Oh, I thought I changed it to purple. Okay, so we get that so far. I'm just going to show you right over here why we can do that. 1 over n over r is the same thing as 1 divided by n over r, which is equal to 1 times r over n, which is r over n. So that's why I could replace r over n with 1 over n over r. Now this exponent of n times t, we can replace that with this hint here. And what we're going to do is we're going to raise this to the power of n over r. And then I'm going to raise that again to the power of RT. And the reason I can do that is because, first of all, the exponent properties, when you have a power to power, you can multiply these. And multiplying n over r times RT is just going to give you, oh man, that's what I meant to do. It's just going to give you NT. All right, my handwriting is terrible. Okay, so that's why we could replace NT with N over R and then raise to the power of R over T. So what we have right now is just a bunch of messy stuff. But if you notice, this 1 over n over r and this n over r here, these are kind of the same thing. So I can go ahead and maybe let x equal n over r and see if we can get it to look a little bit more like one of our givens here. So let x equal n over r. So I will rewrite this then. Okay, so this inside part, this 1 plus 1 over x raised to the power of x, looks a lot like this. And if we're compounding something continuously, that means we're going to take those number of times compounded per year and make them higher and higher and higher and higher. So that n is going to get to be bigger and bigger and bigger and bigger. So, you start with what? Quarterly or monthly or weekly or daily, and eventually you're going to get to continuously. So eventually this n is going to go to infinity. And if this n goes to infinity, that means the top is getting bigger and bigger and bigger, which means x is going to infinity. So I can kind of look at this formula right here and say, limit as x approaches infinity, 1 plus 1 over x raised to the power of x, and that's going to equal e. Okay, so I can take this part right in here and I can replace it with e, which gives me then, that's an arrow, it doesn't look like an arrow. All right, so after replacing this inside part with Euler's number, this looks exactly like the continuous compound interest formula. Okay? So just remember that the whole reason we can use E is because of this definition here, and because x is going to infinity, because n is going to infinity, because we're compounding continuously. That should do it.